9.1 Properties of Parallelograms. Our central question is, what can you conclude about the sides, angles, and diagonals of a parallelogram? And basically, our central question, our answer is the opposite sides are congruent. Okay, that's awesome. Opposite angles are congruent. Nice. And consecutive angles are supplementary. That means they add up to 180. And the diagonals bisect each other. That means they cut each other perfectly in half. So again, here's a rough drawing. This angle is going to be the same as this angle, and this side is going to be the same as this side. This side is going to be the same as this side. This angle over here is going to be the same as this angle over here. And if we have a uh, diagonal cutting across another diagonal, we know that this guy is the same as this guy, and this guy is going to be congruent to that side. Okay, that's basically the answer in the shortest version. All right, so investigating parallelograms. Quadrilateral is a polygon with four sides. A square, okay, it's not perfect, but a square. A rectangle, etc. Okay, you've seen them. Now, a parallelogram is a quadrilateral that has two pairs of parallel sides. So, if you think about a parallelogram, sometimes you see them like this, even though technically a rectangle is a parallelogram. Okay, this side is parallel to that side, and this side is parallel to this side. That's basically what they're saying. All right. Now, a segment that contains or that connects two non-consecutive vertices is a diagonal. So here's this angle, and there's this line coming across connecting to that uh, non-consecutive vertice. The diagonal is that line that I just drew uh, right here. That is a diagonal. All right, so proving opposite sides are congruent. I'm going to burn through this a bit, but basically the theorem states if a quadrilateral is a parallelogram, okay, so they tell us right away that it's a parallelogram, then the opposite sides are congruent. So we're going to prove this. Now ABCD is a parallelogram, and we have to prove that AB is congruent to CD and that AD is congruent to CB. So if we look at this, first things first, they give us the fact that this is a parallelogram. So that's the first part of our proof, okay? We did draw BD, and that's right here, okay? So we drew that because through any 2 points, there's exactly one line, and that's just basic definition of a line. And then AB is going to be parallel to DC, and AD is going to be parallel to BC because that's the definition of what they gave us, which was a parallelogram. All right, parallelogram has to have that, and they kind of marked it right here for us already. How nice of them. All right, and next thing's number 4. They say that ADB is congruent to angle CBD. So, see, CBD is right here, and then ADB is right here. Those look like alternate interior angles. And let's see, do they say something about, yep, ABD and CDB, those two angles being congruent. And that's because of alternate interior angles theorem. Okay, so that's nice that we were able to draw the line. Okay, so now we're moving on. Looks like we're talking about the reflexive property here because they're saying dB is congruent to itself, which is the reflexive property. Okay, so basically this guy is congruent to itself. And then basically what's interesting here is you have this angle. Let me clean it up so you can see what they're going at with this proof. They gave us this angle being congruent to this angle because of alternate interior angles. Thank you, marker or pen, for making my life wonderful right now. Okay, so we have an angle that's congruent to this angle. We have a side that's congruent to itself. Okay, and then we have this angle. Thank you, pen. Wonderful pen. It's a wonderful, wonderful pen. Okay, this angle, which is congruent to this angle because of, again, alternate interior angles. So that angle is congruent to this angle. So we just basically said that triangle ABD, sorry, that's a terrible B, is going to be congruent to the other triangle, triangle CDB. All right, and that's because of angle side angle triangle congruence. So congruency theorem kicks back in, all right? And then finally they say that AB is congruent to CD and AD is congruent to CB, and that's because, well, if those two triangles are congruent to each other, if the larger things are congruent, that means all the smaller pieces, right, should all be congruent. So CPC TC. Corresponding parts of corresponding triangles are congruent. Okay, so that's how that all comes back into the proof. And that was for the sides. All right, so we're proving that AB is congruent to CD, and then that AD is congruent to BC. All right, that's what the proof is all about. All right, now proving opposite angles. Similar idea, similar image. Now we're just focused on the angles. So first things first, they do give us that this object is a parallelogram. All right, awesome. And then we did draw BD again, so it looks like we're still using, and that's because really the definition of a line, because any 2 points, and the points that we used here is D and B, or B and D, because again, any 2 points, uh, there exists one line. Okay, again, just using some Greek representations there. That means this guy means there exists. Okay, now AB is congruent to DC and AD is congruent to BC. That's again the definition of a parallelogram, which they gave us. How nice of them. And then, as you can see in step 4, they're talking about alternate interior angles. So I'm willing to bet that they're talking about angle ADB. Okay, so here's angle ADB. And he's probably congruent to angle CBD. All right, and then lastly, we have angle ABD is congruent to the other angle, uh, what? Angle CDB? Yeah. And again, that's because of alternate interior angle theorems, okay? Now, reflexive property, again, see how the proof is actually very similar to the other proof? In fact, if you look at it, it's actually the same exact proof, just representing two different situations. So we got our angles, our two angles, we got our side, and then we're basically saying the same thing, that triangle ABD is congruent to the other triangle, triangle CDB, because of angle side angle again. And then therefore we can say, well, angle A has to be congruent to angle C, and that is again because of CPC/TC. So basically, it's the same exact proof. It's the same proof as the one before. So that for opposite angles being congruent, it's the same proof used for the same sides. And it's all relying on angle side angle, which follows through with CPC/TC. Okay, so be aware of that. All right, so a little different here. We're still kind of operating off of CPC/TC and all these ideas, but this is about the diagonals. All right, so they do tell us in the theorem, if a quadrilateral is a parallelogram, then its diagonals bisect each other, which basically means that AE has to be congruent to CE, okay, because it's, they're perfectly cut in half, so they have to be the same. And then that BE has to be congruent to DE, and that's exactly what we have to prove here. All right. Now they do tell us that ABCD is a parallelogram, so that's nice. ABCD parallelogram. They gave that to us. Sorry, I can't spell right now. Apparently, parallelogram. There we go. Knew something was fishy when I was writing that out. There we go. All right, and then the definition of a parallelogram is basically saying that AB has to be parallel to DC. All right, and they kind of already do this right here. They mark them with the parallel symbols, which is very nice of them. Okay, and then if you notice here, we have AB. Okay, has to be congruent to DC. And the reason I'm saying that is because opposite sides of parallelograms are congruent, and we already did the proof for that. Okay, so that's nice. So let's think we just proved that this side is the same as that side. Okay, based off the idea of opposite sides of parallelograms are being congruent. We do have alternate interior angle theorem going on here because of AB being congruent to DC. So we have angle ABE being congruent to angle CDE. All right, so ABE is that angle right here. And then CDE is this angle right here. All right, and then they're using alternate interior angle again. Now, I'm willing to say that it looks like they're setting us up for angle side angle again, right? So they're going to say that angle BAE has to be congruent. Thank you, touchpad. Oh, man, you know what? I know what I want for Christmas. I know what I want for Christmas. Oh yeah, I'm gonna throw you in the garbage. All right, BAE. Maybe I'll take you out to a field. That'll be great. And then it's going to be congruent to angle DCE. There we go. DCE. Boom. And if you just noticed, I stepped back and I was like, wait, it looks like they're setting us up for angle side angle. It looks like they are. So basically, we have angle side angle. Therefore, these two triangles, triangle ABE, is going to be congruent to the other triangle, CDE. All right, so since those two triangles are congruent, we could finally say with CPCTC what they want us to prove in the first place, that AE is going to be congruent to CE, and that BE is going to be congruent to DE. Very nice. All right, so let's finally deal with the whole using these properties of parallelograms to solve. All right, so if we're looking at AD and they're asking us to find the length of AD, AD is 7x. Now, isn't it going to be the congruent, the opposite side? So AD is going to be congruent to BC, and isn't BC represented as 5x plus 19? So aren't we just going to set this up to where AD equals CB, which is really just 7x equaling 5x plus 19. Use the subtraction property, and we just solve, right? So we should get, not that, that's a terrible little mess of my pen there. We should get 2x equals 19, division property, yep, x equals 9.5, but that's not what they're asking for. They were asking us to find AD, and there's the dog again. Thank you, dog. It's like clockwork with him. Oh, Kiko. All right, here we go. So AD equals 7x, plug it back in, and you get 66.5. All right, so let me do the legwork on this one. We have to find angle B, all right? Angle B is right here. Now, I do know that the opposite angle of angle B is right there at angle D, all right? Now I know these two should be congruent to one another, all right? So that means angle B should equal the measure of angle D. So I have 6y plus 5 equaling 8y minus 17. Let's go ahead and solve. Let me get rid of the y here. Let me get rid of the 17 here. Thank you, pen, for, man, all night. That pen is just haunting me. It's like torturing me. There we go. All right, so these eliminate. There we go. And we get 22 equaling 2y. Division property. So remember, what you do to one side, do the other. And it looks like we get y equals 11. Now, that's not my answer, but that's what I used to plug in. And angle B was 6y plus 5. So 6 times 11 plus the 5 gives me 66 plus 5. And 66 plus 5 should give me 71. 71 what? 71 degrees. So our measure for angle B equals 71 degrees. All right, so remember, there's a couple things you need to know. Opposite angles of parallelograms are congruent, opposite sides are congruent, and diagonals are perfectly cut in half, perfectly bisect one another. Okay, so those are the three things you need to know in order to move on. All right, so your turn number one, go ahead and find me the length of QR, and then find me the length of PR, which is that diagonal. All right. Um, Notice that x plus 9 is really just representing PT, and TR is represented as that 4x minus 6 expression. So just be aware of that of what they give you, okay? And also, what do you know about QR in relation to PS, right? So those are my hints right there. I just gave them to you. Go ahead and solve for your variable, plug it back in, and you'll get your answers just fine. All right, guys, have a great evening. If you have any questions, let me know.